Okay, so good day, everyone. Our topic for today, of course, is about operating systems, specifically the CPU or the central processing unit scheduling. So what is CPU scheduling? CPU scheduling is a process of determining which process will own CPU for execution while another process is on hold. So the main task of the CPU scheduling is to make sure that whenever the CPU remains idle, the OS at least select one of the processes available in the ready key for execution. The selection process will be carried out by the CPU scheduler. It selects one of the process in memory that are ready to execution. In the CPU scheduling, we have preemptive and non-preemptive as what we have here. Preemptive is the tasks are most assigned with their priorities. Sometimes, it is important to run a task with a higher priority before another lower priority task. Even if the lower priority task is still running, the lower priority task hold for some time and resumes when the higher priority task finishes its execution. On the other hand, non-preemptive scheduling, in this type of scheduling method, the CPU has been allocated to a specific process. The process that keeps the CPU busy will release the CPU either by switching context or terminating. It is the only method that can be used for various hardware platforms. That's because it doesn't need special hardware. For example, like timer and like preemptive scheduling. So, when scheduling is preemptive or non-preemptive, a process switches the running to the waiting state. As what we have here, a specific process switches from the running state to the ready state. A specific process switches from the waiting state to the ready state. And the process finished its execution and terminated. And only condition 1 and 4 apply, the scheduling is called non-preemptive. All other scheduling are preemptive. So important CPU scheduling terminologies. Of course, we have burst time or execution time, arrival time, finish time, multi-programming, jobs, users, process, CPU or input-output burst cycle. Now, we have here a scheduling criteria. We have a maximize and minimize. When we say maximize, that is CPU utilization throughput. On the other hand, minimize is a turnaround time, waiting time, and a response time. Maximize, the CPU utilization is the main task in which the operating system needs to make sure that CPU remains as busy as possible. It can range from 0 to 100%. However, for the RTOS, it can be ranged from 40% for low level, and 90% for the high level system. Throughput, the number of processes that finish their execution per unit time is known throughput. So when the CPU is busy executing the process, at the time work is being done and the work completed per unit time is called throughput. For the minimize, waiting time is an amount that a specific process needs to wait in the ready key. The response time, it is the amount of to time in which the process or the request was submitted until the first response is produced. Turnaround time is an amount of time to execute a specific process. It is the calculations of the total time spent waiting to get into the memory. So waiting in the key and executing on the CPU. The period between the time of process submission to the completion time is the turnaround time. The interval timer. Time interruption is a method that is closely related to preemption. So when a certain process gets the CPU allocation, a timer may be set to a specified interval. So both timer interruption and preemption force a process to return the CPU before its CPU burst is complete. Most of the multi-program operating systems use some form of a timer to prevent process from typing up or from tying up the system forever. So what is dispatcher? It is a module that provides control to the CPU to the process. So the dispatcher should be fast so that it can run on every context switch. So display latency is the amount of time needed by the CPU scheduler to stop one process and start one another. So this will be the functions performed by the dispatcher: context switching, switching to the user mode, and moving to the correct location in the newly loaded program. Now, we have the types of CPU scheduling algorithm. And as what we have FCFS, SJF, SRT, PS, RRS, and MLQS. So the first come first serve is the full form of course, FCFS. It is the easiest and most simple CPU scheduling algorithm. So in this type of algorithm, the process which requests the CPU gets the CPU allocation first. The schedule method can be managed with the first in, first out queue. As the process enter the ready queue, its PCB or process control block is linked with the tail of the queue. So when CPU becomes free, it should be assigned to the process at the beginning of the queue or key. So this will be the characteristics of the FCFS method. The shortest remaining time. So the full burst of SRT is shortest remaining time. It is also known as shortest or SJF preemptive scheduling. In this method, the process will be allocated to the task which is closest to its completion. So this method prevents a newer ready state process from holding the completion of another process. And this will be the characteristics of the shortest remaining time. We have the priority-based scheduling. So this is the method of scheduling processes based on priority. In this method, the scheduler selects the task to work as per the priority. So priority scheduling also helps OS to involve priority assignments. The processes with higher priority should be carried out first, whereas jobs with equal priorities are carried out on a round robin or the first come first serve basis. So priority can be decided based on memory requirements, time requirements, and others. How about the round robin? So round robin is the oldest, simplest scheduling algorithm. So the name of this algorithm comes from the round robin principle, which where each person gets an equal share of something in turn. It is mostly used for scheduling algorithm in multitasking. So this algorithm method helps for starvation-free execution of processes. And this will be the characteristics of the round robin scheduling. Shortest job first. SJF is a full form of a shortest job first. It is a scheduling algorithm in which the process with the shortest execution time should be selected for execution next. This scheduling method can be preemptive or non-preemptive. It significantly reduces the average waiting time for other processes awaiting execution. And listed here is the characteristic of the shortest job first scheduling. Another, of course, is the multi-level key or queues scheduling. And this algorithm separate the ready queue or key into various separate keys or queues. In this method, processes are assigned to a key based on a specific property of the process, like the process priority, size of the memory, and others. However, this is not an independent scheduling OS algorithm, as it needs to use other types of algorithms in order to schedule the jobs. And listed here is the characteristics of multi-level keys, queue or keys scheduling. So, what will be the purpose of scheduling algorithm? So, the CPU uses scheduling to improve its efficiency. No, it helps you to allocate resources among competing processes. So the maximum utilization of CPU can be obtained with multi-programming, and the processes which are to be executed are in the ready key. Again, the CPU scheduling is a process of determining which process will own CPU for execution while another process is on hold. In preemptive scheduling, the tasks are most assigned with their priorities. In non-preemptive scheduling method, the CPU has been allocated to a specific process. The burst time is the time required for the process to complete execution. It is also called running time. CPU utilization is the main task in which the operating system needs to ensure that the CPU remains as busy as possible. The number of processes that finish their execution per unit time is known throughput. So waiting time is an amount that a specific process needs to wait in the ready queue or key. So it is the amount of time in which the request was submitted until the first response is produced. Turnaround time is the amount of time to execute a specific process. On the other hand, time interruption is a method that is closely related to preemption. And a dispatcher is a module that provides control to the CPU to the process. Then, the sixth type of process scheduling algorithms, the first come first serve, shortest job first, shortest remaining time, priority scheduling, round robin, and multi-level queue scheduling. So in the first come first serve method, the process which requests the CPU gets the CPU allocation first. In the shortest remaining time, the process will be allocated to the task closest to its completion. The priority scheduling is the scheduler select the task to work as per the priority. And the round robin works on the principle where each person gets an equal share of something in turn. In the shortest job first, the shortest execution time should be selected for execution next. And the multi-level scheduling and method separate the ready key into various separate keys or queues in this method. Okay, processes are assigned to a queue based on a specific property. And take note, the CPU uses scheduling to improve its efficiency. So that's it. Thank you. And next meeting, we're going to discuss or where we're going to compute, no, on how we'll be able to get the first come first serve, shortest job first, priority, round robin, and others. Good day and keep safe, everyone.